So we have this equation here, and we're supposed to, f is continuous for all real numbers. We want to know what the value of k is. So what we'll be doing in this section is we're trying to find, we'll have missing values in our piecewise function, and we need to find the correct value that will make this function continuous. For this particular case, this x squared minus 4 over x plus 2 is my graph everywhere except for at negative 2. And that is because if I factor this, x minus 2, x plus 2 over x minus, or x plus 2, this is going to cancel, which means what do I have? A whole at x equals negative 2. So I've got a hole in the graph, which means I need to know what y value I need to put here so that I can put me a little dot right there to fill in the hole. Yes. Thanks for checking though, because a lot of times I forget. Alright, so I need to know what value of k is going to make this happen. So when I'm looking for that, I'm looking for the limit. Right? The limit gives me that value for that open circle. So I would do the limit as x approaches negative 2 of, I'm going to just go ahead and do my x minus 2 since I've already factored this. So negative 2 minus 2 equals negative 4. So k should equal negative 4. So this graph, are we okay knowing that we've got a hole in the graph here? Yeah, that's fine. Okay, so just like look at what's going to happen here really quickly. Yeah. Let's use the Wood theorem here. All right. Alright, so the graph here, it looks fine, but right here at negative 2, there's a hole in the graph. But if I, instead, I'm going to call this one g of x just because I've set it up as two separate functions just because it's easier in Desmos. If I just say g of x equals, we said negative 4 was the correct answer, but I'm going to put over here in brackets, this is only for x equals 2, or negative 2, negative 2. Right, so you can't even see it whenever you do that. But now, it may not still work. This still is undefined, but if I can, let me click on this one. It may not show up very well, Thomas. I want to click on it. I got it. Oh, I'm never going to be able to do that. I want to click right on here at negative 2, but that's not even negative 2. That's not going to happen. But, so what that's doing though, Thomas, is it's just putting a point at negative 2, negative 4. This will show up. So you're filling that hole. Right? So you're filling that hole with your dot. Okay? Okay. Let's see. I might skip that. Let's do this. I'm going to skip number 2. We may come back to it. We may not, but we don't have a lot of time. So let's skip 2. 2 is the same thing. You would just do the limit as x approaches, limit as x approaches negative 4. And then whatever that limit is, that's your k value. Yes. Yeah, multiply by the conjugate and solve. And then whatever you get for that answer, that's your k. You plug in negative 4 because here x has to be greater than or equal to negative 20 just because of that square root right there. But this just wants it to be continuous for all x greater than negative 20, so we're not worried about negative 20. We're worried about this point right here at negative 4 is our possible discontinuity. It's gonna usually be obvious by your limit, like your restrictions on your domains here. So like they share that -4. Yeah. Okay, let's look at 3. All right, that was bad. Okay. All right. So for example 3, we want to know for what value of c is the function defined by, and it gives us this equation, continuous at x equals -1. Do we even need to consider 2? No. Like if we wanted to make it continuous everywhere, we would have to consider the values for 2. But we just care about it being continuous at -1. So that means that these 2 functions need to have the same value at -1. So what I'm going to do is I'm going to say -x has to equal -x squared plus x plus c. And what x value does this have to occur at? -1. So I'm plugging in -1 for my x values. -1 equals -1 squared plus -1 plus c. Yeah, c is just the number we're trying to find, right? So we're solving for c. So we got +1 equals, what's that going to give me? -1. When you square, you're going to square first, which gives you a +1, but that negative's still out front. So -1 minus 1 plus c. So -2 plus c. We can add that 2. And so we're going to get 3 for our c.
Yeah, I mean, I understand the other part, but I could never get the c equals 3.
We are setting these equal to each other because we want them to have the same y value, right? When we plug a number in, it gives us the y value. So, at x equals -1, if I want to know the y value, I would plug in -1 here. And if I want to know the y value, I plug in -1 here. And I want those two to equal each other. If they had said it needs to be continuous at 2, we would, but they did not mention 2 here. So we would not for this particular one. Yeah. Okay. All right, here's another one. This one is calculator active. All right, so the function f is continuous for all real numbers. Find the value or values of a. So, e to the ax, is that a continuous function? Exponential, is it continuous? Yes. 2x plus a, what type of function is that? It's linear because a is just a number. This is like 2x plus 5 or 2x plus 24 or something like that. This is linear. Is it continuous everywhere? Yes. So the only place this might not be continuous is at 3, because that's where our 2 pieces of the graph need to meet up, right? So we want them to be equal to each other. So we want e to the ax to equal 2x plus a. And this is going to occur at what x value? 3. So we're plugging in 3 for x, not a, but x. So e to 3a equals 2 times 3 plus a Now, here's the problem. I know I need to do this. 3 e to the 3a equals 6 plus a. We don't know how to solve that. And yeah, because we would know how to do it if we didn't have this a over here on the right hand side, or we should, because we could do natural logs and whatnot. But with this a right here, if we take the natural log of both sides, then we got a natural log of a on this side. And then we'd have to do an e, but then we'd end up with e over here, so it's not going to work. So, calculator active. Check this out. I think it'll work. I believe it'll work. If I do right here F2, it says algebra on that tab right there at the top. So I'm gonna hit F2, and number 1 is solve. So I'm just going to use an X instead of an A because it's easier to type in. But if you want to use an A, you can. So e to the 3x equals 6. There's an equal beside of the parentheses. Close to 7. Yeah, below x. 6 plus x. Alright, so you're going to just type in the equation you want to solve. Equal sign and all. But then you have to tell it which variable you are solving for. So I'm going to put a comma, x, and then close my parentheses. Yes. It takes it a while, but I think it will work. And I probably should have hit my green button. Oh no, it gave me a decimal. Alright, it says questionable accuracy, but it's better than we can do by hand, so we're going to go with it. So we got 0.631, -6, or if you go up here and click over, I don't know why -6 is there twice, but we're just going to go with -6. And there's questionable accuracy, it warns us, but it's better than what we could do by hand, right? So it can solve equations we don't even know how to solve. So our A would either equal 0.631 or A equals -6. We don't know sign of 1. Because sign of 1 would be, like, you need to be either doing radians, so you need to do, like, sign of pi over 2, sign of pi over 4, sign of 0. Sign of 1 is going to be, like, a decimal, but we don't know. It's not a unit circle value. Okay, questions? If you run into one of these with something you cannot solve, you can put it into the calculator. Now, it could be that maybe you should know how to solve it by hand and don't. We'll look at that. I just rounded it 631 and -6. Did everybody get their solve to work on the calculator? Yeah, the comma X is easy to forget. Yeah, it'll solve anything. Well, pretty much anything. There's some things it can't do, but it solves a lot of stuff that we don't even know how to do. Because we don't know how to solve that. Your other option on this is to use the Wood theorem and type in. Your other option on this, if you can't get solve to work, you could do e to the 3a. Let's call it x. E to the 3x. And then 6 plus x. And you can see you get those same intersection points right there. So you could do that on the calculator also. You could type those two into y1, y2 and see the intersection. That's another option if for some reason solve is not working for you. Trig functions, sometimes solve gives you weird stuff. Okay. Alright. So what value of b, if any, will make f of x continuous at, shouldn't have two ats, at x equals 1. Okay? Is this one calculator active? Nope. Wonder if I meant to put a calculator there or not. Let me check the work here. Oh no, we can do it by hand. Okay, so whenever we look at this, we've got less than 1 for this first part, greater than 1 for the bottom part, and then at 1 it equals negative 1. Not plug it in, but put it equal to negative 1, right? Because all three of these pieces have to be equal to each other. Well, negative 1's the easiest piece to set it equal to, right? So if the top has to be equal to negative 1 and the bottom has to be equal to negative 1, we can do those two equations separately.
So you have two separate equations.
Oh,
You could have 3. You could have that equation. That was negative.
yeah, you could do the top equals the bottom, but that'd be painful.
Yes.
All right, so if I do b minus bx minus x squared equals negative 1, I need this to be true at what x value? At 1 over here. So I'm going to plug in 1 for my x's, not my b's. So I get b minus 1 equals negative 1. Uh-oh. B minus b cancels. I got negative 1 equals negative 1.
That's true.
It's true. So it's telling me like any number will work for b right here. But any number might work for b on this first part. But I don't know about the second part. So let's do the second part. 3 over, I'm going to do x minus 4 sevenths minus b. That needs to equal negative 1. And I need to plug in 1 for my x. So I got 3 over 1 minus 4 sevenths minus b equals negative 1. So 3 over, that'll be 3 sevenths minus b. So 3 times 7 over 3 minus b equals negative 1. What happens to those 3's? They're going to cancel. So 7 minus b equals negative 1. Subtract 7, negative b equals negative 8. So b equals 8. So while any number would work for your b in the first part, 8's the only thing that works in the second part. So it has to be 8. Yeah. If we had done the bottom part first, we could just say it's 8. So if either one of these was true, assuming that the problem was set up well, I probably made this one up, but assuming the problem was set up well and was correct and didn't have an error, if we had found an answer by setting those first two equal to each other, we wouldn't necessarily have to do the bottom part. Right. All three of those pieces have to be equal to each other.
Like we could ignore the middle. Because one of the earlier examples we could ignore too because
Right. Right. Because they only asked it about at negative 1. Okay. All right. Questions? The assignment for this is on AP Classroom. I think I might make that progress check. I might extend those out till the end of the day on Monday. So I might give you till 11:59 on that. Probably. It'd probably be a better idea to go ahead and do it this weekend, but just in case you got a busy weekend, I'll give you till the end of the day on Monday.